Often in science we use models to try to make the invisible visible. So we're going to use the PEOE framework here to get students to try to make sense of particles. Particle theory is something that extends right through the curriculum. Without a good understanding of particle theory, students often get lost with some of the more complex activities they're required to do later in high school in physics, biology, and chemistry. So today we're going to use beans. We're going to use various sizes of beans, and these are red kidney beans I just bought from the grocery store. There happen to be 200 milliliters of them here. This is our stand-in for a liquid. And I'm going to ask the students to make a prediction. I have 200 milliliters of beans in this beaker. There are 50 milliliters of beans in this beaker. What I need them to predict is what will happen when the stand-in for liquid in this beaker gets poured into the larger beaker. So what happens when I add the 50 milliliters of red beans to the 200 milliliters of red beans? That's what I'm asking for. And in the initial part of the the first part of the prediction is I'm asking for them to give me a drawing. Okay. Often we're looking at a sequence here. So I would get them in the prediction section to show me a before and an after diagram. So in the before, they may show me a labeled diagram of two beakers with beans labeled. Now, students may decide to try to draw every bean, and that's all right if that's what they need to do. They may draw very, very tiny circles. Others, if they've had some experience with this technique in the past, will realize that they don't have to draw they don't have to represent every bean. But they'll show one, and what I'd be looking for there is some indication of the volume. So there'd be 300 milliliters would be there, and they'd show another representation of the liquid, beans being about the same size and shape in both containers, this being at 50 milliliters. Okay, the after, then they would show me a combined version. You get the idea. What we should see is them drawing the particles roughly the same size and shape at a volume that's at 350 milliliters. Now I've drawn this really quick, very, very quickly. I'd be looking for the students to have uniform size in both. So if I was looking at this, I would say the particles in the 50 milliliter beaker do not look to be the same size or shape as those in the 300 mil. I think we started with, with 200 mils. Okay, so for simplicity's sake, I would say, okay, so in A, the particles look different here. Were they different? No. So then that would be a suggestion I would make for next time. They would have to draw them the same size and shape. Same thing with the combined. We'd be looking at the same size and shape. And what I'm hoping for in the prediction here is that they look at the conservation of volume here. Add the 200, same size and shape, to a volume of 50, you end up with 250. We can also add another level in here and have them actually mass the beans as well. So they'd have a volume prediction, they'd also have a mass prediction.